Cloud migration cost our estimations in pre-sales phase is manual, time consuming and heavily dependent on individual expertise. Estimates are created using incomplete and uncertain informations, which leads to inconsistent quotations. Whenever we generate the quotations, the costs are varying very differently or behaves very differently. Long turnaround times because it is human made, so it takes a lot of time if there is any changes or when we are reviewed the sales data for the win ratio of the quotation generated, and we identified there is a gradual dip in the sales. We did the root cause analysis to identify that we have a high cost and high turnaround time with our quotations. That's why the sales are dipping gradually in the overtime. We interviewed sales team and conducted research and discovered that the problem is really exists because we have a high turnaround time and the conversion is less and the win rate is also less. For the machine learning problem, we identified we have more than 1,000 questions generated and all the documents are labeled and stored in our database. So that's a very good sign because we have the data ready. uh, the heuristic approach, I mean the rule-based system didn't solve the problem because it didn't predict the cost accurately, because it didn't understand the pattern or the market standard or market scenario to create the actual quotation generation. We identified if you create this solution, it will have a low turnaround time, the low cost in generating the quotations because it will reduce the dependency on the senior consultants. There will be a pricing consultancy consistency. So in terms of business impact, it falls under high business impact. In its feasibility, as we have data available, so we assumed that it will be having a high feasibility rate, so it falls into the must do phase for our opportunity. The target customers are the pre-sales, cloud consulting team, cloud architects, solution consultants and sales seniors who are directly in touch with the customers and who approach the customers to gather the requirements and create the quotations for them. Manual, like the way they're creating the quotations dependent on the spreadsheets and ad hoc assumptions based upon their expertise, their expecting. There will be a pricing risk and the over reliance on the senior expertise that directly impacts the revenue and scalability and margin of our company. So right now there is a huge gap in the current how we are solving. So manual estimation doesn't scale with demand. Uh, Produces inconsistent cost or results around teams and provides no visibility into estimation confidence or risk. Created a few success criteria for our machine learning problem. So the business impact will be it should be a faster deal cycle. So the customer shouldn't wait so much to get a quotation from our company. So there should be improved pricing consistency. There won't be any fluctuations or differentiations from the market. There should be low risk will be less because we are creating a system which will give us a confidence scoring on our generated quotation, and the quotations are tool dependent and not human dependent. We can scale it rapidly, and it is less dependent on the senior consultants. So the outcomes and output matrices, what we have identified, like it's a North Star metrics for our business. The first thing we have identified is the pre-sales estimation turnaround time, and we fixed it should be less than 10 minutes to create one estimation. Pricing consistency and consistency should be not less than or more than 20% of fluctuation in our quotation what we have created. Then the output matrix would be estimate generation success rate and confidence score. The estimate generation success rate should be more than 90%. So every time it should generate a estimation, and the confidence on that particular quotation should be more than 80%. So there are few constants what we have identified. Estimates are indicative, not a contract binding. So it is not a final pricing over here, what we are talking right now. And accuracy is limited by incomplete inputs and variability in historical migration data. So many times in historical or migrational data, the few details are missing, details are there. Even when we're creating a new quotation, there might be some missing data or missing elements or missing features should be there. So in that case, the success and the outcome and output matrix can be took help of our senior consultants and identified what are the factors could affect the migration cost. We identified the direct factors, partial factors, and indirect factors, and gathered all the data available in different silos in our systems, and created a data lake around it, so that we can create a data pipeline to build down. Let's talk about a solution what we have created: an AI assisted confidence aware cost estimation that scales pre-sales decisions without removing human control. We have created an AI assisted decision support tool that directly doesn't create a quotation, it just supports our sales team to make the decision, and generates an indicative cloud migration cost, not a final migration cost. It's designed to work with partial and unsettled inputs, because many times the customers of ours, they don't give the full informations, so we have to work on the partial inputs. Yeah, so in the end, we always give a human judgment on accountability, the maximum priority rather than the machine generated output. So our solution creates a cost breakdown and recommended migration strategy and confidence score, not the final pricing. How we are using the machine learning right now is the machine learning learns the pattern from historical cloud migration projects, like what we already did, to estimate. So we have used a tree based ensemble models to analyze structure inputs and handle missing values effectively. The model outputs predicted cost ranges and confidence score, not the direct price from that. When the confidence is low, so we have created a fail-safe mechanism or a kill switch button. When the confidence score is low, the system will back to rule-based logic and flags uncertainty. So we have also included a human factor in that. The humans will review the assumptions and override recommendations and own the final decisions. So the machine won't have the final decision criteria. So always is developing the final model. We did exploration and experimentations. We created hypothesis that if we provide a assisted and confidence where cloud migration cost estimates during pre-sales, consultants will generate faster and more consistent quotations while reducing dependency on senior experts. So we did the hypothesis validation through mock-ups and potential solutions. So we created a mock-up design and tested that with human. So we have put some human in the backend. Then we identified the what data we need for that. We collected a small subset of data. Then we did the exploratory data analysis to understand how the correlations are with the existing target or the cost identification or the quotation generation. Heuristic approach. We mean we created a rule-based system uh, where the users can create a quotations, and it's generally the quotations are reviewed by the senior consultants, and to mark it as it's a actual predictions or not. So we created multiple quotations and gathered feedback to test out different models and their output, and compare the accuracy of different models, and consider the model which has very high accuracy. Creating the system, we had to make few decisions around our machine learning systems. So in place of cloud and edge systems, we are not using any IoT or mobile devices, and products and prediction where latency should be very less. So we are not in that system. So there is no edge systems we are using right now, and we are designing a solution where we are expecting the quotation should be ready in less than 10 minutes. So a cloud-based system will be a great fit for that one. And for the online versus offline learning, we didn't expect our model to train immediately, because the data regarding the cloud migration doesn't change very often. It takes some times to change. choose to train our model in smaller intervals, like in in monthly once or 2 week once. That's how we started with, and we chose to do a offline learning. And for batch versus online predictions, as we are working on a model which generates quotation, and it the quotations has to be time sensitive. So we have selected a online based prediction rather than batch based predictions for this one. There might be a difference between clean training data and incomplete real world inputs, because our customer doesn't give all the inputs right away. So sometimes we have to deal with the missing data. So defaults and unknown values handled inconsistency. So there can be a silent accuracy regression over time. And then there could be a data drift. Cloud services, pricing models, and workload patterns evolve periodically and time wise. So new regions, instance types, and architectures appears periodically. So there can be a gradual loss of model reliability. There could be a concept drift. I mean, changes in delivery methods, automation, and labor rates over the time, and some inputs no longer map the target variables in the recent times. So there will be a systematic underestimation or overestimations. So we should look into that. Sometimes our model can be overconfident about the data, or about the quotation it has generated. So because of the limited historical data for the new workloads and services, model extrapolates beyond learned patterns, because model sometimes overfit our data. So we have to take control on that, and periodically do the audit to check the model efficiency. And with this, we are ending our slide, and this is how we have came up our machine learning solution for code generation or quotation generation for our cloud migration projects.